right? So we ended up on multiplication, division of complex numbers using De Moivre's theorem. So we were saying if we are given these two complex numbers, z1 is equals to r1 cos theta 1 plus I sin theta 1, and also this z2. One under multiplication, you just write this one, the one I have circulated. Under multiplication, you simply multiply your modulus r1 times r2. Then for the angles, you add the angles, right? Then here we are left out with I. It's supposed to have I here. It's I sine of theta 1 plus theta 2. So this one is the first rule that when you are multiplying complex numbers, you simply multiply the modulus, but on the angles you add it. So just know this result. Don't worry about where is it coming from. The proof is here, but don't worry about the proof. Then 2, on division, if we are dividing z1 divided by z2, we are simply going to divide the r, the modulus. It's the modulus of r1 divided by modulus of r2. Then for the angles, you simply subtract the angles. So these are the two laws we use when we are doing division and multiplication of complex number. Right? We have these examples here. We have these examples here that we have. Like for the first one, this example. Before we do this example, let's first of all do this one. You must know, right? We have this example where this complex number is multiplying with this complex number. We don't have the r. In fact, the r is 1 here. So we're saying this is our z1, and here this is our z2. So if we are multiplying these complex numbers, assuming that the r is just 1, it's 1 times 1, you get your 1. So you are going to simply add the angles. So it's pi over 4 plus pi over 4, or pi over 4 plus pi over 6. You add pi over 4 plus pi over 6, and you get cos 5 pi over 12 plus I sine 5 pi over 12 as the answer. Right? Then you must know this special result. Please, you have to write it down. It says sine, if we have sine of negative theta is the same as negative sine of theta. You must know this result. And also cos of negative theta is cos theta. Right, these results, they are very important. You see where they are very important. They're important when our z is got a negative, like we might have z is equal to cos, let's say cos 3 theta. Then we have minus I sine 3 theta. So we use these results because they are very important. Remember, when we defined z1 and z2, we have this positive. Here we have these positive numbers, not a negative number. So now, when we have a negative number, how do we remove the negative number? We then use these results. So we were saying if we remove the negative here, we remove it, then it will be a positive. So it will be positive I sine of negative 3 theta. And here it will be cos of negative 3 theta. So we remove the negative by multiplying the angles with the negative, because these results, they will concur. Like sine a negative 3 theta, it will be negative I sine 3 theta, like this one. We are using this result. And cos of negative 3 theta is the same as, so there is no, the two, they are similar. So now with those two results, you can now understand this one, where we are saying we have this complex number on top, we divide by this one. And we are saying, since we have a negative here, we have to remove a negative and put a positive. So if you put a positive here, make sure the negative is going to multiply the angle of 2 theta. So this one will be the same as this one. So before we divide, we are going to say the denominator is going to be cos of negative 2 theta plus I sine of negative 2 theta. Then now what do you do if they are dividing? We simply subtract the angles. So it will be cos of 5 theta minus 2 theta plus I sine of 5 theta minus 2 theta. Then you are going to get cos 7 theta and I sine 7 theta as your answer. So I think you can now do these ones. Where are they? Can you practice on these ones? This is right. Can you do this one? Can you do number 1 to 5? You can pause this video and try number 1 to 5. And try number 1 to 5. Number 1, you do number 1, number 2, number 3, number 4, and number 5. You can do this one, right? So moving on, we want to look at the locus. We have done the square roots here. We are okay on this one. Right? We are moving on to the locus. I think this is the last concept on complex numbers. On locus, we are going to demonstrate on locus. There are 3 types of locus. This one is a circle. This one is the perpendicular bisector, and this one is a line segment. Okay, let's discuss the locus. Right, so here these are the types of locus. There are only 3. Right, so the first one, the one we are saying in case 1, we have this locus which says modulus of z minus z1 is equals to a. This type of locus is a circle with the center z1 and radius a. Right. For instance, if the question is saying sketch this locus, let's say it's modulus of z minus 2 plus 2i is equals to, let's say, 3. Right. So the first thing you need to do is to identify the type of locus. This one is a circle. Why? We only have the modulus to one side. These are the 3 types, like what I said. This one with the modulus to one side, saying z minus a certain number, it's a circle. Then the second locus, we are going to look at the second locus. There are 2 modulus here. It's a perpendicular bisector. Then if we have the argument of an angle, it's now another line segment. So basically there are 3 types of locus. So the first one is in this form. It is a circle where we are saying the z1 is the center and A is the radius. So here you need to take note of this. Here is always negative. Here it's always negative. And we have this complex number, which we are going to say is the center. So this Z1 must be in brackets so that we identify the center. So we can rewrite this one to what? Let's rewrite this one. We're going to rewrite this one to modulus of Z. We say minus, then we open brackets here. This is going to be our Z1. So if we factor out negative here, we are going to say it's now 2. If we factor negative from positive, it's negative 2i is equal to 3. So now we have managed to come up with the Z. We have a negative which is here, and Z1 is this one. So now let's sketch. So on locus, you don't need the mathematical set, it's just sketching. So your sketch must clearly indicate the radius and the center, just like that. Don't worry about the intercept. Just indicate the radius and the center. The sum of the intercepts they are very clear. Right here, our center is for x is 2. So x here is 2. And y here it's minus 2i. So minus 2i is for y. So here we have minus 2 here. So this one is for the imaginary, which is the y. And here is the real, which is the x. So we have 2 and minus 2. So here is our center, where 2 and minus 2 is meeting is our center. So you just draw a circle. Let's just draw a circle, bearing in mind that the center is that one. We are drawing a circle. Sorry about this. Oh, we are drawing a circle. Make sure indicating that that positive is the radius. So how do you show the radius? You just draw an arrow from the center. And indicate that it's what is 3. Just like that, you will be done. So we have sketched the what? The locus of the first type. So there are 3 examples. As you can see here, we have 3 examples. The first one is saying modulus of z is equals to 3. So you need to write that in this form. Z minus Z1 is equals to A. So as you can see, if you want to write this one in this form, what you simply do is you say Z minus, you open bracket. Since we don't have anything here, it's 0, 0. It's 0 plus 0i is equals to 3. Meaning to say our center is 0, 0 and radius 3. So this will be your sketch. As you can see here, it's obvious from here to here it's 3, and here we will have minus 3. So the intercepts, they are very obvious. You can read. But in this case, don't worry about the intercepts. Then for this one now, you can write it as what? Z minus 1 modulus equals to 1. You can write it as Z minus open bracket 1 plus 0i is equals to 1. So this is your center, 1 and 0, and your radius is 1. So center 1 and 0 is this one, and radius is 1. Obvious, this one is going to be 2, and this one is going to be 0. Or you don't need to indicate. You can say, you can just draw an arrow here and indicate it's 1. Then the last one here, we have the square. We need to remove the square, then introduce the square root. We are going to have square root of 2 here, which is the radius. Then for the center, you say z minus, you open bracket, 1 plus I. So the center is 1, 1, and the radius 2. So here will be your right. So on this one, sometimes you'll be given inequalities. You'll be asked to sketch asked to sketch a locus, but with an inequality sign. Again, it's a circle here. It's a circle. What you simply need to do is to write in that format where you are going to say this one it's z minus. Make sure I have this negative. Then you open bracket. Then plus 1 is the same as you put minus 1. Because we want to say if we remove this negative here, if we remove the bracket here, we're going to get this one. So plus 1 is the same as if we have negative here, then here we should have negative. Then this minus, we are going to have positive, so that if we remove the bracket, we're going to get this one. So the center will be minus 1 and 2, and our radius is 2. Then if we have a less or equal to, then this circle will have a bold line. Then we are saying less or equal to everything inside the bracket. It's less or equal to. So that's why we have shaded everything inside. Our radius, our center minus 1 and 2, and we shade everything inside. If it was greater or equal to, we were going to shade outside. And also, if it was less than, you have a dotted circle. It will be like a dotted circle. So this is the first locus. Then the second locus here, where we are having two modulus to one side, to both sides, like modulus of z minus z1 is equals to modulus of z minus z2, right? So this one, it represents the perpendicular bisector joining z1 and z2. So it represents the perpendicular bisector joining z1 and z2. So suppose you are asked to sketch, let's say, modulus of z is equal to modulus of z plus 1 minus I. So the first thing you need to take note of the type of the locus. There are two modulus here. So if there are two modulus, we now have the perpendicular bisector. You have to write it in this form. So let's write the above in that form, where we are saying z minus z1. So this one is the same as modulus of z minus, then I open bracket. Since I don't have anything, it's the same as 0 plus 0i. It's 0 plus 0i modulus is equal to modulus of what? Z. Then I say minus. Make sure you have a minus. Then plus 1 is the same as minus minus 1. Then this minus, if I factor it, I'm going to have plus I. Then I close the bracket here, right? Then this will be my z1 and this will be my z2. Then I go to the Cartesian plane where I'm going to sketch. So here it's my y and here it's my x, my origin here. So z1 is o. So z1 is on the origin. Then z2 is minus 1 and I. Here I have minus 1. Suppose here it's minus 1 for x. Then I for y. So where the 2 points are meeting is where I'm having my z2. So we are saying the locus is the perpendicular bisector of the line joining Z1 and Z2. So the line joining Z1 and Z2, let me put a dotted line. This line is joining Z1 and Z2 like this. So the required perpendicular bisector. Now, you know a perpendicular bisector. How do you indicate? Just draw a line. I'm not saying it is passing through or -1. I've just drawn. Then if you draw a line like this, it cuts. Draw a line which cuts Z1 and Z2 perpendicular. Then how do you show that it's perpendicular? Just put a right angle. Then you put this. I think you know this, that it means this length, they are equal, just like this. Then you'll be done. So you need to identify Z1 and Z2. After that, you join Z1 and Z2 using a dotted line usually. Then you indicate the perpendicular bisect. So case 2 is for perpendicular bisect. So you can pause this video and go through example A and B, this one. Can you pause this one and can you try on yourself how to come up with this? Then let me scroll down. I hope you are going to get the same results. For A, this is your diagram. You can pause the video. Then for B, this is the diagram. Then example 2 now, they are inequality signs. They are inequality signs. It's saying indicate and describe the region of this inequality. Let's see here. Are they shading the wanted or the unwanted? Let's see. So now let's rewrite this one in our form. This is Z minus open bracket minus 1 plus 0i. And this one is Z minus open bracket 0 plus I. So this is our Z1 and this is our Z2. So Z1 is -1 and 0 is this one, Z1, and Z2 is 0 for X and 1 for Y, this one. So you roughly join by a dotted line, then you draw your perpendicular bisector. But now in this case, our inequality sign is less or equal to. So we are saying you have this line, this perpendicular line. This line, you have this line. And we want a lesser region. Like if we have a horizontal line like this, then this is the lesser region, then this is the upper region. So if we just draw it like this, like the one in the diagram, still our lesser region will be this unshaded region. So they have shaded the unwanted region. So it depends with the question. Sometimes it says shade the region. So if they were saying shade the region, we're supposed to shade this. But in this case, the way they present it, they are shading the unwanted region. Please take note of that. It's very, very important. Right? Let's move on to the last locus. This is the last locus, case 3, where we are having the argument. We are saying argument of Z minus Z1 is equals to alpha. It represents half line segment having one end at Z1 and making an angle alpha with the x-axis. What are we simply implementing here? We are saying we have our Cartesian, here it's our y, and here it's our x. Then we have a point where we are saying Z1. So you need to take note of the point first. You need to write everything in terms of Z in form of this one. Then you plot your Z1. Then how do we draw that line? So at Z1, what you simply do, you sketch the dotted line, the horizontal level at Z1. Just indicate the horizontal level at Z1, but use a faint line or a dotted line. Then the required line is a line from Z1 and it makes an angle of alpha. It makes an angle of alpha with the horizontal. It makes an angle of alpha with the horizontal. Let me adjust my thickness. Fine. So from Z1, we are going to draw a line segment from Z1. And that line segment, it is going to make an angle of alpha. I want to adjust this one. Okay, fine. So this is the angle alpha. So I've assumed that alpha is an acute angle. If it was an obtuse angle, then this will be in this direction. So that is the line segment. This is the line segment that we are talking of. You can pause the video and do the sketches on example A and B. As you can see, this one, you rewrite this one in this form: argument of z minus z1. So here, as you can see, we only have z, so it will be argument of z minus 0 plus 0I is equals to pi over 3. Then we have a line segment starting at the origin and making an angle of pi over 3. Then you just indicate with an r. Then you are done. Can you look at B? Then now, at this example, now we have this one. We want to indicate the region. So in this case, we are going to shade the region represented by this one. So, okay, let me do a different one. Then you can read this example. Suppose we are asked to sketch. This locus. Suppose we are asked to sketch this locus. Argument of z less or equal to pi over 2 here less or equal to let's say pi over 4 or pi over 3. Let's put pi over 3. We want to sketch the region represented by this one. So we say pi over 3 less or equal to argument of z less or equal to pi over 2. So here we are going to say it's pi over 3. Let's rewrite that form. Pi over 3 less or equal to argument, open bracket, z minus, then say here we have nothing, 0 plus 0I. So this will be our z1. It's less or equal to pi over 2. So now let's go to the Cartesian plane. We are now on the Cartesian plane now. We want to sketch. Here's our x. Here's our y. Then z1 is the origin. So this one is our z1. So here there are two angles. With the angle of pi over 2. Pi over 2 is like 90. So at z1 we draw 90. It's along this y-axis. So here we indicate pi over 2. We are measuring from z1. Then from z1 we sketch an angle of pi over 3, which is 60, just above the 45. So for this angle, we can say this one is pi over 3. The pi over 3 is coming from this one. This one is pi over 3 and 90 is this one. So we want to shade the region where we are saying the region between pi over 3 and pi over 2. So as you can see, is the region between. Here in this case, we are shading the wanted region. So this is the wanted region. This is the wanted region. It's how you draw these locus of these inequalities of the third locus. Again, if we have less than only, the line will be dotted like this. If we have the less than only, the line will be dotted. So these are the locus. So the next lesson, maybe we are going to look at questions on complex numbers. So if we revise together, or maybe if I find time, I'm going to record another video where I will explain how we answer questions on complex numbers. But for now, here is your exercise. You can pause the video. I want you to do these ones. There are just a few. On this one, you do number 5, 7 and 3. You do number 5, 7 and 3 for this one. Then for this one, I want you to do number 9, 12, 17 and 18. Can you pause? Then on the next one, I want you to do these inequalities. Here are now inequalities 19, 21. I think no, it's different. 21, 23 and 24. So you do that. So that's your exercise. I think we've done complex numbers. We are now complete on complex numbers. What we only left is to look at some past papers. If we can just answer one or two. But at the same time, I'm encouraging you to revise your notes. Anytime from now, I'm going to give you a test. So good night.